Now we will study about the frictional force, that is a new concept. Suppose you have got a surface, this is a rough surface and a body is placed over here. When the body is placed over here, it presses the ground to this side, not necessary it presses the ground always perpendicular to this. So, we can take this is a reaction here. This reaction has got two components, this is theta, you can take one this horizontal component and this is perpendicular component. Actually this perpendicular component is known as normal reaction and this is the component of the force parallel to the surface is known as frictional force. So, now we will study actually here what is frictional force and how does it act. Suppose you have got a rough surface in this way and you have placed a body over here. When this body tries to move on this surface, so what happens actually, both the bodies are rough, so their surfaces gets interlocked. So, when you move the body to this side, you apply the force and when you apply the force, interlocking of the surfaces, both the surfaces gets broken. Because of that a force acts in opposite direction, which opposes the relative motion of the point of contact with respect to the surface. This force is known as frictional force. So, if you apply the force F here, so a force acting opposite to this, which is opposing the motion of the point of contact with respect to the surface, that is known as frictional force. Now, if you keep on increasing this force, this frictional force also increases to the certain limit. You can understand in this way, suppose if you increase this force and the body is not moving, it means opposite force is equal in magnitude to this. Again you increase this force, again the body is not moving, it means again this force has increased its magnitude equal to this. So, this at this stage whatever the frictional force is acting, that is called static friction. If you keep on increasing this force, a time will come when the body is on the verge of the motion. At that stage whatever the force is acting this side, that is the maximum frictional force, maximum static friction, and that maximum static friction is known as limiting friction. If the body has got mass m here, so mg is acting to this side, normal reaction R is acting to this side. So, we can write here a static friction, that is a limiting friction, is directly proportional to R, and we can write Fs is equal to mu s into R. Mu s is known as coefficient of static friction. So, see here the value of static friction depends on how strong this body presses the surface and also what is the nature of the surface. If the body comes into the motion, magnitude of the frictional force reduces slightly and that stage whatever the frictional force is acting, that is called kinetic friction. And we can write Fk is equal to mu k n in case mu k r in case of kinetic friction. And see here magnitude of kinetic friction is less than the limiting friction. Now, kinetic friction can be two types. One is sliding, another is rolling. Sliding friction, when the body slides or one body slides over the another surface, whatever the frictional force is acting, that is called sliding friction. And kinetic friction in case of the car's wheel, when the car moves on the road, its tire keeps on rolling and whatever the frictional force is acting, that is called rolling friction. Now, you see what is the cause of rolling friction. So, see here when the tire is on the surface of the road gets slightly depressed like this. Also the surface of the tire gets depressed, it gets deformed. When the wheel is suppose rolling like this, moving in this way, this side it gets detached from the surface and this side it gets attached. So, during this detachment of the surface, there is the opposition force is acting, that is known as here the frictional force, which is opposing the motion, that is called rolling friction. So, we have studied here static friction, kinetic friction, limiting friction as well as rolling friction. How does frictional force vary with the external force, that you can study with the help of the graph. Now, we can see graph between force of friction and applied force, because we have seen this here as we apply the force of friction increases and it attains its maximum value, that is called limiting friction. and when the body comes into motion, value of frictional force reduces, and that is known as kinetic friction. So, by graphical study we will see here. Here on x axis, this is y axis. Here we have taken applied force F to this side and frictional force F to this side. Graph is obtained something like that, in this way. See here, this is Fs static friction. This is the maximum value, that is called the limiting friction. And here when the body comes into motion, this is known as kinetic. So, now from here only the kinetic friction, value of kinetic friction is slightly less than the limiting friction. Now, see angle of friction here. What is the angle of friction? For that we can take here angle of friction. Suppose you have taken a rough surface over here, a body is placed here, force applied to this side, frictional force is acting to this side here. So, we can make here this is this side frictional force, weight is acting to this side, normal reaction acting to this side. Actually, this I have drawn taken this point and drawing all the forces at this point. The resultant of these two is acting to this side, and this angle is known as angle of friction. So, the angle between the resultant of the frictional force and normal reaction and between normal reaction is known as angle of friction. We can write here tan theta is equal to F upon R. We can write F mu R upon R, this cancel here. So, we can write tan theta is equal to mu. Now, we can see one more concept, that is called angle of repose. Suppose there is an inclined plane, this is horizontal line, this inclined plane making an angle alpha with the horizontal. Now, a body is placed on this surface, this body is placed over here. So, the minimum angle of inclination of the plane with the horizontal such that this object just begins to slide down, then this angle is known as angle of repose. So, we can take here the weight of this body acting downside, vertically downward. This is normal reaction is acting to this side perpendicular to the contact, that is surface. If you take this is here, this is alpha. We can take two components of mg, that is mg cos alpha and mg sin alpha to this side. Body is coming downward, so frictional force is acting upside, opposing the relative motion. We can write F is equal to mg sin alpha, because body just begins to slide without acceleration here. So, we can write F equal to mg sin alpha, and also R and mg cos alpha are equal and opposite in here because there is no motion. So, R minus mg cos alpha is equal to 0. So, R is equal to mg cos alpha. If you take this first and second and divide this one, you will be getting F upon R is equal to tan alpha, and we know it F upon R, this is mu R upon R is equal to tan alpha. So, R cancels, so you will be getting mu is equal to tan alpha. It means the tangent of angle of repose is equal to coefficient of friction. In angle of friction I have described already, I have derived mu is equal to tan theta. Here theta was angle of friction, so we can write here theta is equal to alpha. So, this is the concept of angle of repose and angle of friction. Now, see acceleration of a body down a rough inclined plane. Suppose you have got inclined plane like this is rough inclined plane, this is angle theta I have taken, angle of inclination. Object is placed over here, mg, that is a weight, is acting vertically downward, that is toward the center of the earth. Normal reaction is acting to this side r. So, this we can take as theta. So, mg cos theta and mg sin theta here. This is a free body diagram I am drawing here. Frictional force is acting to this side F. Now, when the body is coming down with acceleration a, then we can write mg sin theta minus F is equal to m into a, m is the mass of the body. We can write mg sin theta minus mu mg cos theta is equal to m into a, because r is equal to mg cos theta. So, here we can write, we can take common m and cancel, we will be getting here a is equal to g into sin theta minus mu cos theta. So, this is the acceleration of this block, this is here equal to this, which is actually equal to a is less than g. So, when the body is sliding down on an inclined plane, acceleration is equal to acceleration a is less than to the acceleration due to gravity.